So I'm recording now. You can tell me to stop and I'll stop. We already talked about the learning targets. Today we're using I can use linear regression to negotiate the price or sale of a used car. We put our name in, we wrote down learning targets. All right, now we're talking about the line of best fit, the linear regression line. All right, so this line can be used to display a trend and predict corresponding variables for different situations. It is more efficient to rely on a single line rather than the scattered points because the line can be represented by an equation. Remember that y equals mx plus b stuff from Algebra 1? All right, recall that the domain, it's in green, it's a vocab term, is a set of first elements of ordered pairs. An ordered pair is a coordinate pair, a coordinate 4, 10, for instance, where 4 is the x value, 10 is the y value, right? Those are ordered pairs. And the range is the set of corresponding second elements. So here we go. The x values are your domain. They go from side to side. Think my house is my domain. The walls on your house are from side to side. If your house is your domain and the walls of your house is from side to side. And then there's a thing called a mountain range, right? Mountains go up and down. Therefore, mountains go up and down. Therefore, the is what goes up and down. Domain goes from side to side. Range goes up and down. My house is my domain, a mountain range. All right. If we have this data, like each one of these little pieces of each one of these little dots here is a piece of data. That's real information from the real world, hopefully. This line here is a mathematical prediction based on these dots. We're going to use math to make a mathematical prediction of what happens if we suppose there's a linear relationship going on here. All right. If we use this line to make a guess about where the data will lie inside my smallest point and my highest point, all right, my smallest domain and range versus my biggest domain and range, then it's called interpolation, right? Interpolation means I'm going to predict something between my biggest point of real data and my smallest point of real data. That's interpolation. There's another word called extrapolation, all right, or extrapolation. Well, extrapolation means to predict a point outside my data. Like I don't even have data that's out here. But if I was to predict what was going to go on over here, this would be extrapolation or extrapolation. All right. So interpolation is between the data that I have. Extrapolation would be outside that data range. All right, the scatter plot. So I pulled this from a textbook just to give you some idea. But the scatter plot shown from a previous lesson is this is a line from best fit. All right, this is the line of best fit that closely follows the trend of the data points. The blue labels, and I have temperature as one blue label. I cut off the label here on the y-axis. The blue labels are used to identify the axes. That's not axes, it's axes, but will not be shown on the calculator display. So if we do this on our calculator, it's not there. Generally, the distance between the points that lie from the line of best fit determines how good the predictor line is. So here's my line. I can determine how good a prediction this line is based on how far away the dots are from it. And notice this dot touches, this dot touches, this dot touches, that dot touches, and every other dot is either touching or is coming really close. Like there's like this one and this one are the two that are kind of, maybe this one over here too, is a tiny bit far away. This would be a fairly good correlation right here. This would be like a 0.9 or above correlation. These dots are coming really close to that predictor line, which tells me that whatever is going on for X, it's a pretty good predictor of what's happening for Y. All right. If the points lie far from the line is not a good predicting of a trend. All right, so if I had dots over here, if I had dots over here, if I had dots far away from my line, and that would tell me that this is not such a good predictor. Because all my dots lie really close to the line, this is a pretty decent predictor. Well, guess what? There's a number that we can use to measure how good a linear model fits a particular set of data, and that's called the correlation coefficient. The correlation coefficient. We also call it sometimes just R. The correlation coefficient is between -1 and 1. All right, so -1 is a perfect negative correlation. That would mean if I drew a line, every single one of those dots would be on that line, and because it's negative, it'd be going down. Right, a -1 would be a perfect negative correlation. All the dots are on the line and exactly on the line, and the line is going down. A perfect positive correlation coefficient would be a 1, right? Which would mean every single one of these dots would be exactly on that line. They'd line right up perfectly. That would be a 1. Anything in between that, like a 0, means no correlation whatsoever, right? So we use this correlation coefficient as a measure of something between perfect positive or negative correlations, with 0 being completely no correlation whatsoever. All right, negative correlation coefficients show negative correlations. That's as the x increases, the y decreases. So I should see it going down over time. And positive correlation coefficients show positive correlations, which means that as x increases, y increases. This right here is a positive correlation because the line is going up as temperature increases. As temperature increases, the number of water bottles sold is increasing. All right, let's see. If the correlation coefficient is near 0, there is little or no correlation. Correlation coefficients with an absolute value greater than 0.75, which means 0.75 or less than negative 0.75 would be very strong correlations. Strong correlations if the absolute value is 0.75 or greater. Correlation coefficients with an absolute value of 0.3, with an absolute value, that means positive or negative, of 0.3 are weak correlations. So if something that has a 0.3 R value or a 0.25 R value, that's a weak correlation. That's almost near 0. That means that the one thing is not a good predictor of the other. Any other correlation is called a moderate correlation. Personally, anything less than a 0.5 for me is something I don't consider very strong. It's a little bit less than moderate for me, but those are the technical little determinations, all right? All right, so occasionally you're gonna have to find a linear regression line for some data, all right? In this lesson, you're gonna have to do some of that. So here's how to do that. The question is, find the equation of the linear regression line for Rachel's scatter plot in example 1 from a different lesson. Round the slope and the y-intercept to the nearest hundredth. The points are given below. All right, so here's how they're gonna do it. There's the data set, right? When the temperature was 65 degrees, she sold 102 bottles of water. When the temperature was 71 degrees, she sold 133 bottles of water. When the temperature was 95, she sold 237 bottles of water, and so on. All right, here's the solution. Here's the answer. Although it is possible to find the linear regression equation using pencil and paper, it is a lengthy process. In this class, we've done, what's the hardest thing we've done? The monthly payment formula, the time payment formula. Did we do standard deviation in this class? I don't think we've done standard deviation in this class. To find the linear regression by hand is a little bit involved. It's more involved than the monthly payment formula, just to give you an indication, an idea of what's going on there. So we're going to use our calculator. We're going to use our calculator, our graphing calculator, to find the linear regression feature. All right. Does anyone not have a calculator on their Chromebooks? All right. So if you do not, period 6, advanced algebra, right? Go to the classwork tab. Somewhere in here, there's a thing called resources. Right there it is. Once it loads, come on, resources. You can do this. You got to talk nicely to the computer so it behaves. Where is it? Where is it? There, right here. There's this thing called TI-84 on your Chromebook, right? Click on that tab. There's a little document. You can open it up. It gives you step-by-step instructions on how to put the TI-84 graphing calculator right on your computer, on your Chromebook specifically. First, you go to Rock Connect, right? You go to Rock Connect. You log in here. You use your RCSD one-to-one account. You are on, when you log in, there'll be a TI-84 plus calculator icon, right? You click on that, you'll add it to Chrome, and then you'll add app, and then it should be, and then you launch app. And then once you get it on there, you're probably going to want to pin it to your taskbar, but then you'll have that right there, okay? So step-by-step instructions on how to put a TI-84 calculator on your Chromebook. Does anybody need a second to get that done? I'm looking at the chat. I'm looking if anyone's hitting me up saying, wait, Mr. Salt, I need time.
All right. It took a second for some of the other messages.
Okay, I don't see anyone hit me up in the chat, so I'm just going to go ahead and do this. All right, so I have the data. This is actually the solution. This is the answer. So the answer is already done, but let me show you how they got this done. I open up my graphing calculator. All right, I turn it on. All right, it's on. I'm going to press clear. It needs to get rid of everything. I want to go and press the stat button because I want to enter data into my list, statistics lists. So I press stat. I want to edit a list, so I can just press enter right now. And then I have a little menu that looks like list 1, list 2, list 3. All right. Here's a hint. Here's a big advice. Always make your X values go in list 1 and your Y values in list 2. All right. That will save you some headaches in the future. All right. So I'm entering this data, 65. Now I would encourage you to play along at home or in class. Hopefully you're actually going to do this, because just like it's really hard to learn how to play piano by watching someone else play piano. You are going to fit this into your what's called procedural memory a whole lot better if you're following along with me and doing it yourself. It's going to feel like you're learning just as much by just watching me, but I'm telling you, you're not going to be able to remember all the different little procedures quite as easily as if you practiced it. Our brains are deceptive like that. We feel like we're learning when we're watching things, but we're only learning at one level, the level of watching. But learning by doing is a different kind of learning, and it sometimes we don't appreciate how good that is. Okay, so notice how I put 65, 71. So what I'm doing is I'm putting just the first value in each one of these ordered pairs in my list 1, right? 65, 71, 79, 80, 65, 71, 79, 80. You see how I'm doing this? I'm putting just the first number of these ordered pairs because these are the X values. I now want to link up these X values with their Y values. So 65 is linked up with 102. 71 is linked up with 133. 79 is linked up with 144. All right, so I'm entering the data like that. I'm entering all my Y values. We're just doing this in order to build the procedural memory of how to accomplish this when you have to do it on your own. We already actually have the answer. It's not like it's a big mystery. All right, there is my data entered into my lists. Let me give you like 30 seconds to enter the data in your list to finish up. All right. Hopefully that was enough time for you to put that data into your calculator. All right, now I want to do this linear regression thing. I'm going to make my calculator do some math magic. All right. I want to press that stat button. I want it to calculate a linear regression. So I want to go to the calc menu. I go to the calc menu by pressing the right button. All right. Notice right here, it says linreg right there. That stands for linear regression, linreg. I can go down all the way here and then press enter on 4. Or notice how 4 is being highlighted here. I could just press the 4 key on my calculator and it'll go to this menu. Either way. All right. Now, this is where you saved yourself some headache. You already made list 1 your X list, and you made your list 2 your Y list. So you're already good. You can either press the down button and highlight calculate and press enter, or you can press enter a few times and it'll just automatically get down there. When I press enter, look at there, looky there. Look at it, has y equals a times x plus b. That's the calculator telling me that it's did a linear regression. And then a equals 4.4382 and so on. Rounding the nearest hundredth, that becomes 4.44, and that's what they have down here for the answer. That's how they came up with that slope, right? And then it says negative 187.666 going on into infinity. Well, they rounded the nearest hundredth and they said, well, it's negative 187.67. All right, that's how they got this equation for this line, was by running a linear regression in a calculator. Now you can run linear regressions. Yeah, absolutely. So Mr. K, just let William know. William, we have Wednesday office hours is a great time to catch up with us. All right. And Mr. K has an office hours between 10 and 11. I also have another office hours with another different group of students, but if you need to talk to me, I can get you the link to my particular office hours as well. But Mr. K can help you. All right. So let's see here. Where was I? Oh, yes. So this is the equation. They just stuck in the A for A in the equation. They stuck in the B value for B in the equation, and they gave them a whole equation to run this through. And what this tells us is that, okay, the number in front of the X is going to be my slope. It's going to be my rise over run, right? So what this tells me that for every increase of X, I have an increase of 4.44 bottles of water sold. And that the y-intercept of this particular function, the y-intercept is negative 187.67. All right. Okay. So the A is the slope, the M, we normally call it M, but if the calculator for some reason wants to be funny. And so 4.44 is the slope, B is the y-intercept. All right, let me give you a hot second, and I want you to try to do the exact same thing with this data right here. Find the equation of the linear regression line of the scatter plot defined by those points there. So I'm pressing stat. I want to edit some lists. And now I have the data from the old thing in there. So I'm going to get rid of that data by pressing clear, up, clear, enter, right? I pressed up, I pressed clear, I press enter. I'm going over here, press up, I press clear, I press enter. That clears the data in my calculator, and I can begin entering the data in my calculator.
And you're doing the same thing again. You're doing a correlate or
Linear regression.
Yep. So you're gonna get your file and get your other file. They should make this one. Beautiful.
Yeah. Right. And this should be where they should have some outdoor lunch seating right there. Yeah. No, I like the trees for shade and such. No, the trees are fine.
Okay, that's this.
Okay.
When I see trees in my yard, I'm like, because I mean, I want it to look a certain way.
That's not far from the cafeteria. Like they should open up this courtyard for the people to eat. Put a lot of picnic tables in there.
Well, you're right with the shade. I agree with that, but they should.
They could trim. They could trim the trees. Sure. Trees are healthier when they're trimmed. All right, let's talk about it. All right, so I want to put my X values in list one, right? So I see that there's a 1 next to the 56. I'm going to add the 1 first. Then I'm going to put 2 as my next value because I'm just putting in the X values. 4, 3, 5. All right, so I put all the X values into list 1. I'm going to put all the Y values in list 2. 56 is my first Y value. My next one's 45. 30. Did I do something? Did I goof up? I goofed up. Look at that. You gotta pay attention to what you're doing. I need a 20 there next to the 4. The 3 needs a 30. Right? These are called ordered pairs. I got to keep these together. These are real data points. Can't mix these up. All right. I got my 2 lists. My X values in list 1, my Y values in list 2. All right, I'm about to run a linear regression. All right. For those of you, again, just a real quick repeat on how to get the calculator on your screen. Going to period 6, classwork, there's a little section called resources. All right, on resources, there's this thing called TI-84 on your Chromebook. Click on that. There's a little document. We talked about it earlier in class. Step-by-step instructions how to get this calculator on your Chromebook. For now, I guess just play along. You can try to get your calculator in your Chromebook while we're working, however you want to do it. All right, so where was I? Oh yes, I was about to run a linear regression, right? I got the data in my calculator. I press stat. I want it to calculate a linear regression. Press the right button to open up the calculate menu. I go down to linreg. Don't forget, I also have the, I'm recording right now, so this is a video that goes on, will go online, and you can watch everything you're missing from class. All right, I got list 1, I got list 2. I'm pressing enter a few times to get this. Okay, there it is. There it is, folks. All right. It told me that it's going to be a linear model. All right. I told it to run a linear equation. So it's going to be A times X plus B. And then it tells me what A is. A is negative 11.9, right? Negative 11.9. B is 67.7. So I took the Y equals AX plus B. I substituted the number for A. I substituted the number it gave me for B. And this is an equation for a line, right? I see that the slope here is negative 11.9. So whatever this is, I don't know what the data is of, but I can tell that for every increase in X, this function is going down 11.9 units. All right, for every increase in X, I can see that this equation is going down 11.9 units, which tells me this is a negative linear relationship because the slope is negative. All right. So I think I added this extra. I don't think we need this. We already looked at this once. Maybe I put this in just for the data. I'm going to ask you this question. Approximately how many more water bottles will Rachel sell for each 2-degree increase in temperature? All right, let me put that in the chat. Approximately how many more water bottles will Rachel sell for each 2-degree increase in temperature, given this function here? If 4.44 is the slope, and if minus 187.67 is the y-intercept, if the temperature increases 2 degrees, how many more water bottles will she sell? This is kind of an indication of, do you understand what a slope is in a linear function and how it works?
Don't take points off of it.
Okay.
The other way. Because when I looked at it, I didn't see the negative on these in terms of.
Oh, yeah.
I don't see the negative very well. But he
Okay.
got the right answer. You want to change it? You can write it.
Yeah. All right. So how many more water bottles will Rachel sell for each 2-degree change in temperature? Well, so this is for Rachel. Remember, we already had Rachel here. We already put this data in there. The slope tells us everything we need to know about this. If this is linear regression is the model for what's going on with this data, then every time the temperature increases by 1 degree, she will sell 4.44 more bottles of water than she will if it went up 1 degree, right? So what we can do here is we can say, well, 4.44 times 2 should be 8.88, right? She'll sell approximately 9 more bottles of water if the temperature goes up 2 degrees. So the answer for this one over here is, between 8.88 and 9, right? Normally I would tell you to say, with this kind of question, you want to say 9 because you can't sell 0.88 bottles of water. But I won't take off if you say 0.88. That's fine. So let me give you an idea. Actually, I won't tell you how. I'll give you an idea of what this is because we're about to do this next. Actually, I will. I'm gonna break the surprise. Okay, let me show you how this works in the real world. I have this formula, right? I'm gonna use this y equals 4.44x minus 187.67. Let's say it's 70 degrees outside. It's 70 degrees. Well, the slope tells me she sells 4.44 for each degree in temperature Fahrenheit. It's 70 degrees out, so I put 70 in for x in the formula. And then I subtract 187.67. And it'll predict how many bottles of water she will sell if the temperature is 70 degrees. She will sell about 123 bottles of water if the temperature is 70 degrees. Let's see how many bottles of water she'll sell if it's 72 degrees. All right, 72 degrees. There's the slope, 4.44 times 72, because now it's 72 degrees outside, minus 187.67, because that's the linear regression. Based on the data we have so far, we can predict that she will sell about 132.01 or 132 bottles of water. Let's see what the difference is between these two numbers. There's that number. minus this number. The temperature went up 2 degrees. It went from 70 to 72. And look at that, 8.88 again. That's exactly how slope works in a linear function, right? If the temperature goes up 2 degrees, well, then we've added two 4.44s to our output. Okay, now we're going to learn about how to basically, we're going to learn what I just said. Rachel is stocking her concession stand for the day in which the temperature is expected to reach 106 degrees Fahrenheit. How many water bottles should she pack? All right, this regression gives her an idea of how many water bottles she should pack in her concessions wagon if the temperature is 106 degrees. All right, so linear regression equation tells us the approximate number of bottles she should sell given a specific temperature. Substitute 106 for X in the equation and then compute the Y, the number of water bottles she should expect to sell. So here's our linear regression equation again, 4.4 times X minus 187.67. We've just taken X and we've inserted 106 degrees, all right? 4.44 times 106 minus 187.67. We could predict that she will sell approximately 283 bottles of water, right? We can't sell a fraction of a bottle of water, so 283, we round to the nearest water bottle. She should stock at least 283 bottles of water, right? This is an example of extrapolation because 106 degrees Fahrenheit was not between the high and low values of her domain, right? She didn't have any data in her data set that gave her an idea of what would happen at 106 degrees. Like her highest temperature that she had data for was 100. 106 is greater than that, so this becomes an extrapolation. Okay, 70 degrees would be an interpolation, right? Because she had some 70 degrees, yeah, she had some 65 and 70 degree data. Okay, so I want you to find me, how many more bottles of water will she sell if the temperature is 105 degrees? You tell me in the chat on your Google form, how many more bottles of water will she sell if the temperature is 105 degrees? Oh, someone. Awesome. Isaiah, I completely concur. Well done. Right, Isaiah, exactly. She can't sell 0.53 of a water bottle. Therefore, we have to round it up. I would take either answer there. But yeah, sometimes math runs into real life, right?
If you're in a country and they're starving for water, they might buy like 2 water bottles. They're like, yes, they will. I just did it.
If I let you drink half the water bottle, how much would the other half of the water bottle cost? You know.
Exactly.
All right. So to show you how this works, good. I'm glad that people are getting done here, right? I got 400. I'm sorry, 4.44 is my slope times X. What's my X? 105, 105 degrees Fahrenheit, right? And I'm subtracting 167. No, 187. Ooh, gotta get that right. Yeah, gotta get that right. All right, and then I run it, and so it's 278.53, right? We can't sell 0.53 of a bottle, so we'd say 279. Right? I would probably even take 278 as close enough. That's an idea of how we're doing this. Okay, next question is, if Rachel's concession stand only sold bottles of water, if her little hot dog cart, or in this case, a cooler water bottle cart, only sold cold bottles of water at the beach, and if the temperature was 42 degrees outside, what do you think Rachel should do? What should Rachel do if the temperature is 42 degrees outside? I want you to explain. Oh, wait, did I skip one? I skipped one. So I'm asking, there's another question here. How many water bottles should she pack if it's 83 degrees? That's what I get for scrolling too fast. So you're answering these two questions here.
How many
How many water bottles should she pack if the temperature is 83 degrees? Is this interpolation or extrapolation?
Yeah, like, there's 17 is one.
And what should she do if it's 42 degrees? All right, let me talk about how this goes. All right, I won't even give you the answer for this. I will point out that we have a function. So you could, if you wanted to, you could use the y equals for this thing. You could press the y equals button and do 4.44 times x minus 187.67. You could do it this way. I'm just showing you a different way of doing it. I'm going to go to the table now. I'm going to press the second and graph button. That brings me to the table. See tables in blue there. And I could scroll all the way down to 83 degrees. And this is why I don't do it this way usually, because I don't like to sit here and wait for it to get to 83 degrees. There is a way to do it quicker. But there we go. So if x is 83, then my y value should be 180.85. My advice to her, if the temperature was 83 degrees, she should pack at least 181 water bottles, right? At least 181 water bottles. As to the example, is this example interpolation or extrapolation? Is 83 degrees within her data set? Does she have data when the data, yeah, she has 80, she has 86. She's got data in between 83 degrees Fahrenheit. So this is interpolation. All right, this is interpolation because 83 is within her data set. What should she do if it's 42? All right, let's go back to our calculator. What should we do if it's 42? I'm gonna look for 42 degrees Fahrenheit. When x is 42, 4.44 times 42 minus 187.67 gives me a negative number. It's actually negative 1.19. What should she do if it's 42 degrees out and she sells only water? She should probably stay home, right? She probably should, yeah, don't pack water. Start selling hot chocolate. Good idea. Isaiah, you've got a business like mine right there. She starts selling something different, right? Yes. Right? She should either stay home or start selling something different or find a different gig, right? Or just take the day off. Okay. So that's to answer those. Okay, now we're gonna talk about correlation coefficient. Correlation coefficient. We're gonna find the correlation coefficient to the nearest hundredth for the linear regression of Rachel's data. Interpret the correlation coefficient. All right. To do this, we're gonna use a graphing calculator. I'm not gonna show you how to do this by hand. You all can take a sigh of relief. Let me show you though. It's actually kind of tricky on how to make this happen using your calculator. So let me go to stat. Let me go into edit. I don't have the data anymore. Okay, so anyway, if I press stat and I go to calc and I go to linreg, I want you to just put this image in your head for a second. This is what happens when I turn this calculator on for the first time. I just get A and I get B. All right, but this calculator can do correlation coefficient, but you have to turn stat diagnostics on, and I will show you how to do that. I'm going to press the mode button. It's the mode button. That's the magic mode button right there. Gives me this little menu here. All right, pressing the mode gives me this little menu here. Let's see. I'm going to press the up button to go to the next page, to go to the page above this one. And then right there, you see that? It says stat diagnostics. You see how off is being highlighted? If I go up here and I go to the right and select on and press enter, what I've just done is I've turned stat diagnostics on. Let me show that again to you, show how you do that. I press the mode button. I press up. I see stat diagnostics and I want to highlight on and press enter. Now magic has happened behind the scenes in the calculator where it will give me the correlation coefficient. All right, so a second ago, we just looked at what happened if I linreg. I press stat, I'm gonna go calc, I'm gonna linreg again. I wanna show you how it's different. Now I don't have Rachel's data in my calculator right now, but looky there, looky there. I don't have just A and B anymore. Now I've got this thing called R. R is the correlation coefficient. For the data I have in my calculator right now, the correlation coefficient is negative 0.99, which tells me it has extremely strong correlation coefficient. That's a negative correlation coefficient. All right. For Rachel and her data, her R value was 0.97. That's a very strong correlation coefficient right there. All right. So the next question gives you an idea, like as you think about correlation coefficient. Anything that's 0.9, I should be able to draw a line through it, and the points should be near, the dots should be very, very close to that line. So you can see kind of here, I could probably draw a line right in here, and these points would all line up pretty decent to that line. The correlation coefficient of this graph right here is probably 0.9 or maybe 0.85 or something like that, or greater. If I look at this data here, I can kind of see that I might be able to draw a line through this data right here. All right, but if you can notice that I draw that line and those dots are nowhere near where that line would have to go, right? If I try to draw a line through the middle of this data set, it's going somewhere in there, and the dots are nowhere near the line. This here is going to have a correlation coefficient of like 0.5, right? It's kind of a line, but barely 0.5 correlation of R value. So the A is going to be your answer here, right? If she found a correlation coefficient of 0.49, this is what we'd expect it to look like, something like that. This would be 0.9 or higher. This is a very strong correlation coefficient. This 0.49 tells me it's fairly weak to moderate. That tells me it's kind of there, but kind of not. All right. All right. Woof. Shoo. Okay, we have 5 minutes. In 5 minutes, I'm going to talk about D of Nayeli, but I'm going to have you work on the rest of this whole form. Okay. You're going to talk. Here's Nayeli. She's trying to buy a car. She goes online. She finds a car with 21,000 miles on it with a price of 22,000. She finds another car with 30,000 miles on it with a price of 19,000, and so on. She finds a car with 55,000 miles on it, selling for 15,900. You're going to enter this data in your calculator, right? You're going to go in your calculator. You're going to go Stat, Edit. You're probably going to have to delete some data that's already in your calculator. Clear, up, clear, enter, right? Up, clear, enter. You're going to enter this data in your calculator. After it's in your calculator, you're going to run a linear regression, and that will give you a linear regression equation, which will go here. The next question will tell you to find the correlation coefficient, right? You're going to have to press you have to go to your calculator, press the mode, turn that stat diagnostics on, and then when you go run that lin reg, it'll have the R value for you. That's how you'll find the correlation coefficient. All right. Oop, I don't know what I did. Oh yeah, I deleted all my data, so it's not happy with me anymore. Then you're going to tell me, is your regression equation a good predictor of the price? All right. And then I'm going to talk in about 2 minutes. I'm going to talk about D here. I'm going to talk about D. And then the other questions are about how much money Franklin Upper School students spent on snacks, the seniors. And it's a stem and leaf plot. You're just going to answer some stem and leaf plots. And then when you're done with that, you're going to have to answer all those questions on stem and leaf plots. You're going to click submit at the end of this form. All right. So I'm going to stop sharing. I'm going to check back in with you in about 2 or 3 minutes.